Assalamu alaikum dear students, hope you are fine by the grace of Almighty Allah. Welcome to NIVS Home School. I am Sabreena Haque, Assistant Teacher of Science, National Intel English Machine School, Day Shift. Dear students, today I am going to take a chemistry class for class 9 student on the based on chapter 4, and the name of the chapter is periodic table. So let us move forward to today's topic. Dear students, periodic table is the most important chapter of your basic chemistry, and you have to learn this table for your basic knowledge of chemistry. If you don't learn about the periodic table, you can't understand any of the topic of the chemistry. Now come to introductory part. A total of 118 elements are identified on each of the up to the year 2016, and study research in chemistry requires some idea about the physical properties and the characteristics feature of all these elements. Some of these elements among them show common features, and there had been effort among the scientists for a long time of group such elements together and put all the elements in a chart. It took hundreds of years of efforts of various scientists, numerous changes and extensions to get such a complete table so far, which is known as the periodic table. It is a significant achievement of chemical research. A sound knowledge of periodic table and its feature enable anyone with knowledge about not only the element but also the compounds formed with them. And come to the background of periodic table. In 1789, Anthony Lavoisier first divided the elements like oxygen, nitrogen, hydrogen, phosphorus, mercury, zinc, sulfur, etc. into metal and non-metal. Lavoisier started with only 33 elements. That time only 33 elements discovered, and scientist Lavoisier divided the total 33 elements into metal and non-metal substances. Now come to the next point, that is in 1829 scientist Boron found that the group of 3 elements showed the same kind of feature, and first he organized the elements into 3 according to their atomic mass, and he marked that the atomic mass of the second element is about the half of the summation of first and third atomic mass. If you observe here, the atomic mass of sodium is 7. In first group, if you observe the periodic table, atomic mass of lithium is atomic mass of lithium is 7. Now sodium is 23. Lithium 7, sodium 23, and atomic mass of potassium is 39. Then if this 2 is added, it will be 46. If we divided it by 2, we will get 23, and that is the atomic mass of sodium. That scientist Boron found that, and this he give the law of triers. Then and then he marked the atomic mass of the second element is half of the about the half of the summation of the first and the third atomic mass. Then Boron identified the chlorine, bromine and iodine as the first trio of the chemical elements. Then it is known as the Boron law of triers, and this is the important thing. Now come to the in 1864, an English scientist John A.R. Newland gave a theory is called Law of Octet. Just now we have learned about the law of triers, and now we are going to learn about the law of octet. Now according to it, if elements are organized following a sequence of lower to higher atomic mass, there will be evident similarity in physical and chemical properties in 8 elements, and this is known as the law of octet. And in 1869, Russian scientist Mandalas published a table in an attempt to contain element with the similar properties in the same group. And reviewing the physical and chemical properties, he theorized the physical and chemical properties of elements written periodically as the atomic mass of the element. Dear students, this is the theory given by the Russian scientist Mendeleev, but it is corrected later on. Then following this theory, he organized 63 elements identified. Till then it is 8 vertical column and 12 horizontal line, and thus he proved that elements belonging to each column have the same physical and chemical properties, and in each line they change gradually as the progress of left to right. The table was named periodic table, and now we are learning about the modern periodic table, but it was the previous and first periodic table. Now come to the next page. Another success of Mendeleev table is in his correct forecast about the existence of some elements. He kept some cell in his table blank, as there were only 63 of them detected till then, and later on these cells were accommodated by the detected elements, providing Mendeleev correct. And there are some flaws of Mendeleev table. According to his theory, elements was lesser atomic mass was supposed to be set before the elements with the higher atomic mass. And come to the periodic table. This is given to your book, page number 63 and 62 and 63. And this is the modern periodic table, which is first proposed by Mendeleev in 1869. And according to his table, Mendeleev was supposed to suggested to arrange the elements according to their mass, but there will be some problem. Where the problem? The problem is on argon and potassium. The argon's atomic mass is 40 and the potassium atomic mass is 39. According to the Mendeleev's theory, we have to put the potassium in this row, but it is the inert gas row. Argon is the inert gas, but potassium is not an inert gas, it is the alkali metal, and argon is not an alkali metal. And again come to the tellurium and iodine. If you observe the tellurium's atomic mass is greater than the iodine, but if we put the tellurium here, it is the halogen gas, and iodine is a halogen, but tellurium is not a halogen. That's why according to the Mendeleev theory, we can't arrange the argon and potassium and tellurium and iodine as their atomic masses. Now come to next part of the. In the 1913, the scientists mostly proposed to organize element according to their atomic number. Then we just find out the atomic number, and we know atomic number is identical for an element. Then instead of atomic mass, when the table was recognized according to atomic number, the elements argons, it is the atomic number is 18, come automatically before potassium, because potassium is 19. Then that is the flow of Mendeleev tables was corrected, and this is the corrected Mendeleev theory. That means we have to organize the elements according to their atomic number, not according to their atomic mass. And there is UPAC, the International Union of Pure Applied Chemistry, has so far detected 118 elements. Then UPAC supervised the controls of different matter of the chemistry and applied chemistry, like the creating of various rules and regulation, observing which is escalating changes or invention are to be accepted or the discharge, etc. Now Lavoisier studied only the 33 elements, which is become 63 detected by, and the 4 undetected elements in the Mendeleev table. Now the atom has turns out to be modern periodic table with 118 detected element. Now we will discuss about the periodic table. For this we have to go to the modern periodic table again. If you observe, there is 1, 2, 3, 4, 5, 6, 7 horizontal row, and this 7 horizontal row is known as the period of the periodical table. The 7 horizontal row is known as the 7 period of the modern periodic table, and there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 group. That means in a periodic table there is 7 period and 18 groups, and there all the periods start with group 1. This is the group 1, this is the alkali metal group, and from there all periods start with group 1 at the extreme level and extend up to the group 18. And a small table, 2 horizontal row, look from here, from the period 6, atomic number 57 to 71, the lanthanide group, lanthanide series is given here, and from atomic number 89 to 103 from the group group 3, and the period 7 is given here in the actinide series, and the period, these are the part of period 6 and 7 of main periodic table. And period 1 contains 2 elements, only hydrogen and helium. Period 1 only contains 2 elements, hydrogen and helium. And the period 2 and 3 contains 8, that means 1, 2, 3, 4, 5, 6, period 2 and 3 contains 8 elements each. Period 1, 2, 3, 4, 5, 6, 7, 8. Period. I am saying, sorry, mistakenly I say count the groups 1. In the period 2 and 3 contains the 8 elements, and period 4 and 5 contains, period 4 and 5 contains 18 elements. Period 6 and 7 contains 32 elements. Period 6 and 7 contains 32 elements each. That means period 6 also has 32 elements according to along with the lanthanide series, and period 7 also has the 32 elements along with the actinide series. And group 1 contains 7 elements. There is from hydrogen to francium, that is 7 elements, and group 2 contains 6 elements. Group 3 contains 32 elements along with the lanthanide and actinide series. And group 4 to 12, group 4 to 12, it contains the 4 elements each, and group 13 to 17 contains 18 elements. Group 13 to 17 contains 6 elements each. Group 13 to 17 contains 6 elements each, and group 18 contains 7 elements. And this is the inert gas group, and this is the halogen group, and this is the actinide series, and this is the this is the lanthanide series, and this is the actinide series. And now come to the how we will recognize the atomic number, mass number, and the symbol of a element. Look, this is shown in your book, chromium. Chromium is the symbol of that element, Cr, capital C and small r, and it is placed in group 6. It is placed in group 6, and this is the number of period. This is the number of period. That means 4 is the number of period, and in the top there is written in the left side the atomic number, and the right side the atomic mass, and in the lower of part of the symbol the name of the element, that means chromium. Like this way we have to recognize all the elements, and at least you have to, for your SSC level, you have to at least learn about, memorize about from the number 1 element to up to number 50, atomic number up to 50. That means up to 10 you have to, at least up to 10 you have to memorize, and it is very much important for you. Now come to the determination of position of the element in the periodic table from their electronic configuration. We can easily determine the group and the period of an element from the electronic configuration of that element, and the system of finding out the place of an element in the periodic table is discussed below. First one, the determining of period number. How we will find out the period number? Come to here, we will think about the sodium. Sodium atomic number is 11. Then electronic configuration 1s2, 2s2, 2p6, 3s1. Now this last principal energy level indicate the last principal energy level indicate the period. That means sodium kept in the period 3. Look, that is put it in the period 3. We can easily find out the number of period with the outermost main energy levels electronic configuration of the electronic configuration, the period of the element. And come to the determining the groups. The group number of an element can be determined in a number of ways. The first system, there is 3 systems. If the outermost energy level of an element consists s orbital only, the total number of electron in the s orbital is the group number of that element. The electronic configuration of hydrogen is H1, that means 1s1, since the outermost energy level of hydrogen consists only s orbital and it consists only 1 electron, so the elements belongs to group number 1 of the table. If you think about the sodium, it is only also has the outermost orbital is the s orbital and is also 1 number, so it is stay the first group. It is stay the first group. And come to the system 2. If the outermost energy level of an electron consists of s and p orbital only, the total number of electron of the s and p orbital added with 10. If the group number of the element, the electronic configuration of the boron is atomic number is 5, that the electronic configuration is 1s2, 2s2, 2p1. Here that 2 is indicate the period, and s and p orbital has the 3 electrons. So along with these 3 electrons we have to add 10 more, then we will get 13. That is boron is kept on the 13th group of the periodic table. Now come to the next system, that is system number 3. The outermost energy level of an element consists of s orbital which is preceded by d orbital. In the inner level, the total number of electrons in those s and d orbital is the group number of that element. And that means the electronic configuration, if you see about the iron's electronic configuration, the atomic number is 26, then is 1s2, 2s2, 2p6, 3s2, 3p6, 3d6 and 4s2. That means this first the electron enter into s orbital, then it comes to d orbital, then 6 plus 2, 8. Then we have to add only this portion's electron. There is 8 electron, that means iron is kept on the 8th group in the periodic table. Now we have to follow this chart and we have to complete the chart of electronic configuration of the elements, and there we have to find out their groups. Here they show some, and I also done some things, that lithium 1s2 2 that is 3, 1s2 2s1, then it will be straight. This is the period, that means 2, and it only has in the last, that means s orbital, it will kept in the first or group, then it is followed by system 1. Come to the beryllium, that it has the 4 electron, 1s2, 2s2, that 2 indicate the period, it 2 will be the period, and the s has the 2 electron and it will put the group number 2, then it also followed the system 1. Come to the carbon, 1s2, 2s2, 2p2. Here 2 is the period number and the number of electron of s and p orbital is 2 plus 2 4, and we have to add 10 with that, and the total will be 14. Then carbon is kept in the 14th group of the periodic table, and this follows by the system 2. Now come to the sodium. It has 11 electron, 1s2, 2s2, 2p6, 3s1. Now this 3 is the period number, and come to the how we will find out. This is last orbital is s, then it will stray the first group, and it is follow the system 1. Now come to the aluminium. 1s2, it has 13 element, 2s2, 2p6, 3s2, 3p, 14, 3p1. Now the period is 3, and we have to add this 2 plus 1 plus 10 is equal to 13, and the group number of aluminium is 13, and it followed by the system 2. Now come to the sulfur. 16 electron it has, 1s2, 2s2, 2p6, 3s2, 3p4. Now it is the period number 3, and 2 plus 4 plus 10 means 16. The group number of sulfur is 16, and it is followed the system 2. And now come to the scandium. Then it has the 21 electron, 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. Then 4 is the period, and the number of electron in D and S, 4s and 3d is 3. Then it's stay in the third group. It stay in the third group, and it follows by the system 3. Now come to the next page. Iron. 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2, and 4 is the last principal energy level, so period number will be 4, and group number will be 6 plus 2, 8, and iron is in the 8th group, and it is followed system 3. Dear students, this chart will be your homework. You have to complete all 30 elements electronic configuration, and you have to find out its period number and the group number also. Now count to the electronic configuration of the elements are the main basic of the periodic table. The electronic configuration serves to identify the group and the pairs of an elements in the periodic table. Again, elements having the same electron arrangement in their outermost orbit belongs to the same group, and on the other hand, the elements with different configuration of element in their outermost shell belongs to the separate group. If you observe the first group electronic configuration, here the hydrogen only has in the s orbital 1 electron. In lithium it only has the last orbital s orbital 1 electron. Sodium also this. If you observe the outermost orbital level and the number of electron of all the elements, last orbital is s, and they has only 1 electron. That's why they put it in same group. Now come to the helium. Helium's has S2, that means in the s orbital it has 2 group. Then beryllium, it has also 2 electron in the s orbital, and magnesium also 2 electron in the last orbital, and calcium also has 2 electron in the last orbital. That's why they are put also in the same group. The element with 1 electron in the outer shell generally tend to give away the electron and becomes positive ion. Sodium has 1 electron in its outer shell, so it donates the electron and become a positive ion. Look, sodium has the only 1 electron in its outermost shell, and it want to give up 1 electron and it want to get stable phase. And again, the element which has 7 electron in the outermost shell gradually tend to accept an electron and become negative ions and become stable. And chlorine has the 7 electrons in its outer shell, so it accepts 1 electron from and becomes a negative charged ion. And if you observe that chlorine has 7 electrons and it takes the 1 electrons in it becomes negative charged ion, and it also becomes the stable phase. Then so electronic configuration helps to determine the position of an electron elements in the periodic table and explain their various characteristics as well. Therefore, the electronic configuration is considered as the main basis of the periodic table. Now come to the some exception of the periodic table. Dear students, first exception is the position of hydrogen. The hydrogen is a non-metal, however the periodic table displays hydrogen alongside strong electropositive alkali metals like sodium, potassium, rubidium, cesium, francium. Then in group it is because the outer shell of the hydrogen contains only 1 electron like the alkali metal. Besides, many properties of the hydrogen are similar of those of alkali metals. On the other hand, hydrogen is also able to accept an electron like the halogen elements like fluorine, chlorine, bromine, iodine, meaning that it has some similarities with halogen in terms of properties. However, since most of the properties of the hydrogen have the similarity with alkali metals, it is placed alongside the alkali metals. Dear students, come to the next exception, that is the position of helium. The electronic configuration of helium is H2, that means 1s2. According to the configuration, it was supposed to be positioned in group 2, but the elements of group 2 are strongly electropositive. They are called the alkaline earth metals. On the other hand, the helium is an inert gas. The properties are similar to other inert gas like neon, argon, krypton, xenon and radon, and its properties are not at all the similar like alkaline earth metals. Therefore, helium is placed alongside the inert gas in the group 18th. Now last exception given in your book, the position of lanthanide and actinide group. The lanthanide elements are supposed to be set in the period of 6 and group 3 of the periodic table, and the original position of actinide group is period 7 and the group 3 if they are placed in this position, and that hamper the beauty of the table. Therefore, to maintain the beauty of the table, these two groups of the elements are moved to the separate table just beneath of the main table. Look, this is given here. This is given here in the beneath of the main table. This is the main table, and this is the lactanide series and actinide series, which is belongs to this group 3, and period 6 lanthanide series and actinide series belongs to group 3 of period 7. Now dear student, this is your homework. You have to make the you have to copy the table and you have to fill up the table of 4.01 electronic configuration of elements and their groups. You have to find out their groups and the period number also. You have to copy total table and you have to complete the table by yourself. Dear students, I have finished my today's topic. This chapter is too much important for you. Read the chapter again and again and learn the periodic table from 1 to 50 atomic numbers, all elements name, their groups, their pairs and their atomic number and atomic masses. Okay, thank you. Allah Hafiz.